Okay, so in this case, example one, where we're naming lines and planes, you're going to see that this is pretty straightforward once you feel comfortable with those vocab terms. So in the first part, we want to find the name of a line containing point Q. So if we're looking for point Q, it'd be right here. And we'd say, what's the name of a line containing point Q? So using the choices provided, write the additional names for line C below. So they don't want you to just say, well, it's line C. They've already labeled it. They want to say, out of these choices, what could it be? Well, it could be TR. It could be RQ. It could be TQ. Could be the opposite order of any of those. So we could say RT, QR, TR. Okay, so any of those combinations of 2 points that are on that line will do the trick. So as long as our name contains two of these letters, T, R, and Q, any two of those, so T and R, not R and V, T and Q, not V and T, R and Q, Q and R and T, not T and S, not V and R. Okay, so which ones did I mark off? Well, it was basically anything that had, V or S in it. So this guy, tried to do it so it's not messy here. This guy was not a possibility. This guy was not a possibility, not that one or that one, but everything else, those other 1, 2, 3, 4, 5, 6 remaining options are all fair game for naming this line right here, this line which they're calling C. Okay, what about part B here? In part B, we're saying we want a plane containing point S and point T. So S and T, and it needs to be a plane. Okay, so basically all that means is that, okay, so let's just read this. One plane that can be named is plane A, right? That's the one that's already drawn. You could also use the letters of any three non-collinear points to name this plane. Okay, so as long as they're not in a straight line, you can define this plane. Remembering that if you use T, R, and Q, 3 points that are in a line, so 3 collinear points, you can't really define plane A as being the only option. Because if you turned plane A, if you turned it, okay, the definition of a plane has to have a certain direction. So you can't turn the plane and say this is still plane A. You'd have to call it something else. It'd be a new plane if you turned it. But in the way that this is working, let's say T, Q, and R are, the end of my finger, the middle, and the joint here. So if T, Q, and R are on that line, well, they can exist in many planes. You can turn them through plane A, B, C, D, E, F. They can be in arbitrarily many planes. But as long as we have a non-collinear set, so like, for example, S, T, and R are not in a straight line, those 3 points only exist in this plane. There's not another way you could turn it and keep them all together. Okay. So you could also use the letters of any 3 non-collinear points to name this plane. Plane TRS and plane TQS can be used to name this plane. So they're saying TRS, TQS, as long as they're not 3 dots that are in the same line. Okay, circle another correct name for plane A. So take a look at these and think about which one of these would also work. Which one of these 3 points exists, which one of these sets of 3 points are non-collinear, okay, are existing in one plane, this plane A. Okay, so anything with a V in it would be a no because V is not in plane A, right? V is not a part of plane A, so you could not list it as one of 3 points that defined plane A. Okay, well, this has a V, this has a V, and this has a V, so really the only option is Q, S, T, right? What do those 3 points make? Well, any 3 points makes a poorly drawn triangle. Okay, God, that was terrible. Anyways, makes a triangle. That triangle exists in the plane that contains those 3 points.